Okay, sorry for delay. It seems the server is busy, so I couldn't upload the PPT slides. And instead of that, I had to upload a PDF. Okay. In this week, this is the last week of this term. Please note, this is the last week, the 16th week of this term, the last week. Here in this week, we want to have a small lecture about the physical layer. Physical and layer 1 and layer 2, something between them. We will talk about, we will start with talking about switches, and then we talk about VLANs, and after that we have some small lectures about, small talks about MPLS and data center networking. Okay. What is a network switch? Inside a network, we have 3 different connecting devices inside a network. The first one is hub. Hub is a small device that with multiple ports. It works on layer 1, just in physical layer. If a hub receives some data from one port, it will resend those data, that data, in all into the rest of ports. It means that if I have, for example, if I receive, if I have a 4 ports hub, a hub with 4 ports, okay, and this hub receives some data from port number 1. Those data will be resent from port number 2, number 3, and number 4. It means that the hub will be broadcast the received data. It will resend those data into all ports. Just exclude the receiving port. It will resend those data into the other ports, all of other ports. What does it mean? It means that if, for example, if I want to send some data from port number 1 to number 2, at the same time, I couldn't send data, for example, from port number 3 to port number 4. Why? Because the data received from the port number 1 will be resent over into port number 2, number 3, number 4. So those ports are busy. Like the hub cannot send or receive other data. It's a limitation, I know. So what's the solution? The solution is using switch, especially Ethernet switch. Ethernet is the most attractive technology in wired network. It's dominant in wired network, in wired LANs. When we talk about Wi-Fi, Wi-Fi is a wireless copy of Ethernet. Okay? In wired network, for LAN, we are using Ethernet. In wireless, we are using a wireless copy of Ethernet. We call it Wi-Fi. Okay? So, instead of hub, I'm using a switch or an Ethernet switch. This switch works on layer 2, on data link layer. In the physical layer, the only things that the hub will receive and it can sense is some signals. And the hub has not any knowledge about those signals. So the hub cannot filter those signals. For example, sending this signal into port number 2, only port number 2. Don't send this signal over, for example, port number 3 or 4. But in switch, the switch works on layer 2, on data link. In layer 2, we have frame, we have MAC address, the address in layer 2, or physical address, MAC address or physical address. We have frames. So a switch can understand the frames, especially the Ethernet frames. It will receive Ethernet frames, and the switch can check them and resend them, forward them to other ports. And in that frames, we have MAC addresses. So the switch is capable to send those frames. I will talk about them one at a time. Okay, the switch can send the data to a specific port number. Why? Because it can learn those MAC addresses. So it can selectively forward, okay, this packet should be forwarded over this port, or this frame should be forwarded over this port, this one should be forwarded over this port. Okay, it can select, it can choose the destination port. Why? Because it works on layer 2, and in this layer we have MAC address. We have MAC address. Okay. One more thing. Switches never change the contents of frames. Never. In a router, as we talked, in a router, when a packet arrives to a router, the router will handle the header of the packet. And, for example, it will reduce the TTL by 1. Okay? It will recheck the checksum and doing something like that. Maybe it changed some other information. Maybe we can, for example, make segmentation over a packet, a received packet. Okay, so a router can change the content of a packet, but a switch cannot. Switch cannot. A switch just check the header of a frame and forward the received frame over a specific port number. So the host cannot detect the switches of the switches in a network. This switch is something transparent over the network because it's just like a bridge over the network. A bridge from a bridge connecting one host to another host. Okay. So the host unaware of presence of switches. That switch is transparent because the switch does not handle, does not make changes in the receive frame over the receive frame. So nobody knows about those switches. Switches are plug and play devices. What does it mean? It means that I need to put them into the network, connecting some cables to them, plugging some cables to them, and it works. There is no necessary configuration in the switches. It's something different when I compare a switch with a router. If I want to use a router, firstly I have to configure it, and after that, after config, I can use a router. But for switches, it's not necessary to configure it. Yes, if you have a manageable switch, or a layer 3 switch. A layer 3 switch is something near to a router, a hardware router. You know, inside a router, we have lots of software capabilities. But a layer 3 switches is a switch with hardware capabilities, with some limited hardware capabilities of layer 3. So layer 3 switches can be used in a state of a router, but we should be aware this router, layer 3 switch, has limited capabilities. So it's better for us to use a specific router instead of a layer 3 switches. And if you are using a manageable switch, this manageable switch has some managing capabilities. Okay, if you decided to use those capabilities, you can configure your switch. Okay, you can configure it, but those capabilities are not barrier against the basic role of a switch. The basic role or the basic functionality of a switch is forwarding frames between different nodes inside a network. Switches work inside networks, but routers works between networks. If you decided to send information from one network to another one, you have to use routers. But inside a network, you don't need to use routers. Simply, you can use Ethernet switches. They will forward your data, and they are plug and play. You just need to plug them into the network. It works. Okay. How they can find the destination? How they can filter? They can filter using those MAC addresses. But how they can find those MAC addresses? Because we are saying I'm saying that switch works by itself. It does not any configuration. Okay. A router needs configuration to apply a routing protocol, and using that routing protocol, it learns the passes toward different destination. But how a switch knows about those destinations? Okay, how it discovered those destination addresses? Because it's self-learning. This is a capability inside uh, Ethernet switches. Okay, but before talking about those self-learning techniques, let me talk about something else. Uh, this switch here connects 6 different hosts together. And as you can see here in this figure, the system host A is connected to host A prin, B is connected to B prin, and C is connected to C prin. Okay, and they can send simultaneously without any collision. It's a full duplex connection. Sorry for interrupt. Okay, those hosts are connected together. And at the same time, they can transfer their data at the same time. A is sending to A print, B is sending to B print, C is sending to C print. Okay, without any collision, without any disruption, without any problem, any other problem. But how? How? Because it uses MAC addresses to filter the ports, the sending ports. What does it mean? How it sends those data? Is there any dedicated routes from, for example, port A to port B? Not. No. There is no dedicated path. Is the Ethernet switch uses a routing protocol? No, it does not. Can, for example, here, look at here, A is sending data to A print. For example, can C send data to A print simultaneously at the same time? No. A is sending to A print. At the same time, C cannot send information to A print. It's because of collision. The path between the switch and A print is busy, so C cannot send information simultaneously at the same time to A print. Yes, this switch has some buffers. Okay, it has some buffers. So the switch can buffer, for example, the receive frame from C. The switch can buffer it, can put it in the queue, and send it later. Yes, if we do something, do something like this, putting the receive frame into a queue, and after a time, one by one, sending those frames into inside the queue toward the destination. Yes, if we do something like this, we can send traffic with the receive frames from A and C toward the C print, but one by one. At the same time, we cannot send. When A is sending data to C to A print, at the same time, I cannot. The switch cannot send the received information from C to A print. Okay. We called about something, we called about self-learning. But what is self-learning? As I said, self-learning is a mechanism that a switch learns about destinations. But how? How does it work? Okay. Firstly, we should talk about a switch forwarding table. What is switch table or switch forwarding table? Switch table or switch forwarding table is a table similar to routing table or forwarding table. Forwarding or routing table is a table in layer 3. We have something like that. Okay, we have something like that in layer 2. We call it switch table. In layer 3, we are talking about IP addresses, but in layer 2, we have MAC addresses. So when we talk about switch table, instead of having IP addresses, we have MAC addresses. MAC addresses and the interface connected to that MAC address, and also a timestamp. Okay, so a switch table is similar to a routing table. In routing table, we have IP addresses and also mask address, mask of that address, and destination port. Here, I have MAC address plus destination port. Okay, they are completely similar together, but one of them is in layer 3, the other is in layer 2. And using this table, the switch can learn about the MAC addresses. How? For example, A is sending data toward the network. Okay? A, for example, system A has a MAC address of A. For example, this system has a MAC address A. MAC address is a 48 bits address. IP address version 4 is a 32-bit address, but MAC address is a 48-bit address. It's the address of your network card, your physical network card, the MAC address. Okay. When A sends a frame toward the network, toward the switch, this frame will receive to the switch, for example, over the interface or over the port number 1. When switch receives this frame, it checks the switch table. If it has a record for this address, okay, it can forget it. But if there is no record in the switch table for MAC address A, this switch will write it. How? A record. I receive MAC address, a frame with MAC address A over the interface number 1. You get this? I receive a frame with MAC address A over the interface number 1. What does it mean? It means that after this, if I decided to send information to MAC address A, I can send it over interface 1. That's easy. Yes, also we have a TTL here because the configuration of network maybe changes over the time. So we have a TTL. This TTL means that this record will remains just for a few minutes, and after that it will be the switch will erase that record. because maybe the configuration of the network changes. I don't know. So we put a TTL field in the record in the table for this reason. This record will be raised after a few minutes. After, for example, 60 seconds. After 60 seconds, I will raise this record because of changes in the network, okay? Managing changes in the network. So the switch learns in this way. Let me continue this example. This frame here is sent by a system with MAC address A toward a system with MAC address A prime. Okay, the frame is arriving to this switch. The switch learns about the MAC address A. Okay, MAC address A is arrived over interface number 1. Okay, but what about the destination? The destination is A prime. The switch will look for A prime. Where is A prime? A prime. If the switch learns about A prime, in the past, if the switch learned about this A prime in the past, it can find, okay, A prime is all, I can reach to A prime over this interface. Okay, it can learn, can find it over this table. And okay, A prime is over, for example, port number 4, interface number 4. Okay, so, the switch will send it over number 4, over port number 4. But if there is no record in this table, it means that the switch does not know about the destination. And at this time, when there is no knowledge about the destination, at this time, the switch will act like a hub. It means that the switch will send the receive frame from A, will be forwarded over the rest of ports, over the rest of ports, all of those frames. This frame would be forwarded over port number 2, number 3, number 4, number 5, number 6, all of them. Again, if there is a pre-knowledge about the destination, the switch can find those knowledge in the switch table, and it finds the destination port, destination address, destination interface, and the switch will forward those frames over that destination interface. Okay, and everything is finished. But if there is no knowledge about those destination, the switch acts like a hub. It will broadcast the received frame over the rest of interfaces, over all of those interfaces, other interfaces. Okay, it will send over all of those interfaces. We call it self-learning, this mechanism. So after a while, different hosts sends packets over this network. Okay, after a while, switch can learn about all of those devices inside the network, especially because we talked about DHCP protocol. We talked about it. We said that when a computer associated into a network joins into a new network, this computer will look for its IP address in that network. using DHCP server. Okay, so simply that computer, that newly arrived host will send a DHCP packet. Okay, the switch will learn. The switch will learn will learn the data using that using this strategy, this self-learning strategy. So as soon as a system sends the first packet, only the first packet, the switch learns the position of that system inside the network. But the host inside the network never can understand about the position of switch, because the switch is transparent from their point of view, from their sides. Okay. For example, here A sends a frame, so the switch write a record. Okay, A is MAC address A can be received over interface number 1 with TTL16. And after that, this packet is forwarded, broadcast. It will broadcast over the rest of interfaces. After a while, the system A' reply that message, that frame to A. And at that time, the switch learns about the A'. Okay, A' can be, I can reach to A' over interface number 4. The switch write those information into its switch table. And after that, if the switch receives a frame for A', simply it looks for into its switch table, and okay, A' is our interface number 4. So the switch knows about that destination. It just selectively send the frame over only one link, only over one link. So the switch, using this strategy, the switch cut the collision domain. Collision domain means the area that if one device sends information, the other devices must not send. They should be quiet until the end of sending, and after that they can send. Okay, this is the collision domain. When I'm talking about hub, using hub has a collision domain, one collision domain over all of its port, over all of its interfaces. It means that if you send information over one of the hub's port, or one of those ports, the hub cannot send or receive information over the rest of ports. It means that all of those ports are placed in a single collision domain. But using this strategy here, using this self-learning strategy in switches, the switch can cut the collision domains. A can send information to A', B can send to B', C can send to C'. That's easy. The switch cut those collision domains. So we have several collision domains. We can send more data at the same time. We can send more data simultaneously. Okay? But What will happen if we have a large network? If we have a large network, for example, in the university have different faculties, and each of those faculties have several buildings, several parts. Their buildings have several parts, for example, floors, classes, rooms, other parts. Okay, we can put a switch over those floors, those sections, those parts, and then we can connect them together using using another switch. It means that I can make a hierarchy in my network inside a faculty, inside a building. I can make a hierarchy. Several small switches in different parts of the building, in different floors, and after that, in a higher level, I have a stronger switch to connect those smaller switches together, and maybe I can aggregate the traffic received from all of those stronger switches into a bigger switch, and then I can connect it to the backbone network of the university. Okay, so I can use a hierarchy when I'm using switches. I can use a hierarchy. Okay, and still, the important notes. Still, even using those hierarchy, still my switches can use their self-learning capabilities. Still they can. What does it mean? It means that instead of using one single string and multiple switch, I can use several smaller switches, and then I can connect them together in a higher level. Why? Because in chapter 1 we talked about cables. We talked about UTP, twisted pair cables, especially UTP, and also we talked about fiber cables. Fiber cables are too expensive, but twisted pair cables are cheap. So simply, I can use smaller switches and connecting different hosts using connecting different hosts to those smaller switches using UTP cables. Okay, and after that, only I can use fiber cables to connect those smaller switches to the strongest switch inside the building. So if it's necessary, why I should talk about necessity? Because if you want to use UTP cables, twisted pair cables, the length of that cable cannot be more than 90 meters. It cannot be. The maximum span length is 100 meters. But never use this span. Use 90 meters. The longest UTP cable has 90 meter length. So maybe inside the building you have a span wider than this. Okay, maybe at this time you have to use fiber cables to connect different items together. At that time, you need to pay more money for fiber cables. But in the small areas, just simply I use UTP. I use cheap UTP cables. It's a good option. Okay. One more thing. Here I'm talking about UTP cables. If your network is placed in an industrial area, for example, inside a powerful planet, at that time you cannot use UTP cables. You must use, for example, FTP cables or SFTP cables instead of UTP cables. FTP or SFTP cables have some external shield and foils protect them against external noise in industrial areas. Okay. So here in this case, again, those switch number 1, number 2, and number 3 can learn the addresses inside their networks using the switch number 4. Okay. So I have a university. This university has a core switch. This core switch is connected to server rooms, for example, to the mail server, to web server, to Golestan server, or something like that. Okay. And in the other side, it connects to switches in different faculties. And those switches may be connected to switches in another layer. So here you can see a hierarchy switching inside the university. But when we talk about IP addresses, all of this area, all of this cloud has the same IP subnet. All of the university, all of the systems in the university are placed inside a single IP subnet. But physically they are spread over different networks, over in different buildings. Okay? You can expand this figure, expanding this network in each of those faculties. So if I try to compare a switch against a router, I can say that both of them are working in a sort and forward manner. Both of them. Switches are working in layer 2 and routers are working in layer 3. Are working as a stored and forward device. Okay? But the router is using forwarding table and routing protocols, and the switches are using switch tables and self-learning mechanism. You can see here, my packet is sent over this network here, and this switch. Look at this one. This switch has only 2 layers, layer 1 and layer 2. But this router has 3 layers: physical layer, link layer, and network layer. This is the difference between the switch and the router. A switch works inside a network, and a router works between the routers. Okay. Let's do one more things. As we talked, a switch learns about the MAC addresses. Okay, the switch learns about MAC addresses, and it filters the received frames according to their destination MAC address. But for example, I have some different parts or departments inside the university. Some departments, for example, computer department, electrical departments, engineering department, science department, and something like that. Okay, and also I have some other parts, for example, education department, financial department, finance department, managerial department. Okay, there are several parts. And if I relay using switches, maybe traffic inside one of those departments, for example, the finance departments, okay, or the managerial department. Those traffic can be sent over this network, over layer 2, into, for example, computer department. But why? Why I should receive those data in another department? If I receive those data, for example, the financial information of the university would be broadcast over the computer department. It has a security issue. It has a security issue. And also privacy issue. I am in another department. Why I should receive the information from another department? Yes, maybe sometimes I need their departments. That's correct. Maybe sometimes. But most of the times, I don't need their information. So I should look for a mechanism to make this limited. We have something, we call it in the network, we call it broadcast domain. A broadcast domain is a domain that if I send some broadcast information, the whole host inside that domain, inside that broadcast domain, will receive those information. I'm broadcasting some information. All of computers, all of systems inside my broadcast domain would receive those information. And now we are talking about layer 2. In layer 3, yes, I can filter those data using the IP addresses. Yes, in layer 3, I can filter them, but I'm in layer 2. And according to the broadcast role, the switch will forward broadcast messages, broadcast frames to all of its interfaces, because it's a broadcast message. It's a broadcast frame. So the broadcast domain is a domain that if I send a broadcast message, all of connected devices inside the domain would receive that information. A bigger broadcast domain has several security and privacy issues. Also, a big broadcast domain makes some inefficiency in my network, because I said the broadcast message, broadcast frame, will forward over the whole network, over the whole broadcast domain. It means that I cannot send other information simultaneously, because the message, the frame is broadcast. The switch must forward the broadcast frames over the whole interfaces. So we are looking for small broadcast domains inside the network. When we are talking about, for example, ARP packets, when we are talking about DHCP packets, when we are talking about unknown MAC addresses. In all of these cases and some other protocols, the sources, the hosts, are sending broadcast messages, are sending broadcast frames. So this strategy is not efficient. What we can do? In this case, we can use VLAN or virtual LAN. VLAN or virtual LAN is a logical concept. It means that I am creating a LAN logically. I am creating a logical LAN over one or more physical LANs. Creating a logical LAN over one or more physical LANs. What does it mean? For example, look at here. The LAN on the left of this image, the LAN on the left has a single user inside the EE department. Physically, this device here in the right is a member of EE department, electrical, for example, electrical engineering department. Okay. So I cannot send information from the computer science into the EE department. If I send information, all of these computers inside the EE department can receive the information. What can I do? I can create a virtual LAN and add all of those computers, especially this one here in the EE, into this VLAN. Again, a VLAN is a virtual LAN, is a logical LAN. So logically, I create a LAN with these computers inside, for example, the computer science department, and this one here, a computer from the EE department. This is a logical LAN. Logically, I connect this computer in the right side, to the computers in the computer science department. Logically. I have to do this because in a simple form, I have to send the whole information here in this computer science department from into the EE department. But I said that this strategy is not efficient. This strategy has several security issue, privacy issue, something like that. Efficiency, something like that. Okay. So when we are talking about a logical device, how does it work? To create a virtual LAN or VLAN, firstly, the switch inside the network must support VLAN. It must support VLAN. Why? Because physically, if my switch does not support VLAN, physically I need to use two separated switches, something like this. Okay, one separated switch in EE and the other in CS, computer science. Okay, using two separated switches to connect those systems inside each of those departments. But instead of using two separated physical switches, I can use one bigger switch that its ports are separated logically. How? I'm enabling different VLANs over this switch based on the port numbers. If you configure some switches, for example, Cisco switches or something like that, you can see that you must enable VLAN, and then you must enable VLAN, define a VLAN, and then you must assign different port numbers of the switches to that VLAN. So I have a single switch, but its ports are divided between different VLANs. It's similar to use two separated switches. When we are using port-based VLAN, firstly, the switch will isolate the traffic. The traffic of VLAN EE VLAN is separated from the traffic of CS VLAN. Those traffics are isolated from together. I know, still I'm working on layer 2, but using VLAN information, the switch will separate their port numbers, their traffics over their ports. Maybe sometimes you can define VLANs over different port numbers, but sometimes maybe you can use MAC addresses, defining a VLAN based on MAC addresses. Okay, it's another option, another alternative. It's an alternative option, defining a VLAN over MAC addresses, not over interfaces or something like that. Okay, but totally I can say that okay, the switch have to isolate the traffics based on the defined VLANs. Okay. The second advantage of VLAN is dynamic membership. You can make it configure, make some VLAN configuration to accept dynamic membership over different VLANs. Maybe it's depend on you, but also you can use a static membership. If you are in a small department, maybe you can, it's better to use dynamic membership, but if you are working in a large network, if you are placing in a large network, it's better to use a static membership because of security issues, something like that. Okay, because the data sent over a VLAN will not send over another VLAN. So the Trudy, the hacker, the intruder, if the Trudy decided to sniff the data of a specific VLAN, firstly it has to connect to that VLAN to receive the information of that VLAN. So if you use dynamic membership, the Trudy can join to VLAN easily. So if you are using a small LAN, okay, maybe dynamic membership is okay, but in a large network, never use dynamic membership. Instead of that, use static membership for joining to a specific VLAN. And also, sometimes we need to send information from one VLAN to another one. What should we do here in this case? Sending information from one VLAN to another VLAN. If you are decided to send data from one VLAN to another one, you have to use a router. You have to use a router. Okay, you have to use a router. Your data should be sent over that router, and that router can add traffic from one VLAN to another one. Why? Because the router works in layer 3. So the router does not have information about the VLANs. The VLANs are in layer 2. Okay? VLANs are in layer 2. So we send information to layer 3, to a router in layer 3. And at that place, the router does not know about VLANs. So simply forward data to another switch. Using this strategy, I can combine the information between, and can forward the information between different VLANs. Especially using this case. For example, you have a VLAN in one site, and you are deciding to send your information to a VLAN in another site, in another send information to a VLAN in another site in a far location, okay, from the first one. So simply you can send your VLAN information over the routers toward that remote sites. For example, you are a network manager in a bank system or big organization. That big organization have several branches in different locations in a city, inside a city, or inside a country, I don't know. Okay, you can define different VLANs and then you can send the data in different VLANs over those routers. But in this case, you need to firstly, you need to define an IP-stick tunnel and then send information over those routers. Be clear about this one. Firstly, you have to create an IP-stick tunnel and then send information over that tunnel toward the destination. But a better option in this case is using VPLS technology, virtual private line switching. If you decided to extend a VLAN over a WAN or to a remote site, it's better for you to use VPLS technology, or at least if you are working inside a country, the better option is use VRF technology, virtual route forwarding. I have to talk about MPLS firstly, and then you can learn more about VRF. Okay, but the simplest case is using this, joining a VLAN, attaching a VLAN into a router, attaching the switch into a router, and then send information, send VLAN informations toward the router. That router can combine the received information between, can forward the received information between different VLANs. Okay. Okay. We talked about a special case of VLAN. I said that, okay, I have one more user. I'm working in computer science department, and I have a special user inside the electrical engineering department, EE department. What should I do? How can I connect to that? How can I connect my network to those users, or connecting them to my network, or something like that? Okay. Firstly, I have defined the CS VLAN inside my network and the CS VLAN in that far network in EE department. Okay, I'm defining some ports for CS in that remote department, and then I'm using a special port. We call it trunk port. What is a trunk port? Trunk port is a special port inside the switches that you can use that trunk port to connect two different physical switches together. So the trunk port is a pass, is a bridge to connect two different physical switches together. So I can extend a VLAN over that trunk port into another physical switch. But if we extend the span of VLANs into multiple switches, we have to use protocol 802.1q.1q. 802.1q protocol. We have to use this protocol. In this case, when we use this protocol, look at this one here. We put this payload, this is the simplest, this is the Ethernet frame, simple Ethernet frame. Okay, there is a preamble, a destination address, source address, a type, and payload and CRs. This is the standard Ethernet frame, 802.1 Ethernet frame. This is the standard frame. But when we talk about 802.1q or .1q frame, look at this one here. We have the standard frame of Ethernet plus here a 2-byte tag protocol and some tag control information. 16-bit, 15 bits tag control information. 2 bytes tag protocol identifier, it's an identifier, plus 15 bits tag control information. 12 of that is VLAN ID and 3 bits for priority. Something like task bit in IP. Okay. So the difference between the frame, the standard frame of Ethernet, and the frame of protocol 802.1q is this 4 bytes extension here. We are adding 4 bytes here. 2 bytes tag protocol identifier and 12 bits for VLAN ID and 3 bits for priority. We are adding this information. Why? Because I decided to send VLAN data into another network. I decided to send this data from one network to another one, to another network. From VLAN inside one network to a similar VLAN in another network. At that case, I have to use protocol 802.1q or 0.1q. Okay, I have to use this protocol. Otherwise, I cannot use this. So inside the university, I have several VLANs, and over that VLANs, because the university has several faculty buildings, and each of those faculty buildings have several parts. Each of those buildings have several parts. So I have to use several switches. Those switches are 802.1q VLANing protocol capable. They have to know about VLANing protocol, especially 802.1q. Especially, they have to know. Otherwise, I cannot use VLAN here. But it's a necessity inside my network. I have to use this one here. Okay, that is enough for today. Is there any question? Any question?